In this video, we're going over the concepts for Lab 11, which is testing for functional groups. The experimental goals are students will be able to recognize structures of functional groups, and students will understand how chemical tests are used to identify functional groups. Let's first begin by discussing what is a functional group. A functional group in organic chemistry is going to be an atom or a group of atoms that are going to replace hydrogen atoms in a hydrocarbon. Understand that functional groups in the area of organic chemistry are responsible for the different physical and chemical properties in an organic molecule. Now we are going to learn what are the different functional groups that exist in organic chemistry. The first functional group that we are going to learn is about hydrocarbons. Like the name implies, these compounds are going to be composed of carbon atoms and hydrogen atoms. Thus, the word hydrocarbons. Understand that in the family of hydrocarbons, the functional groups that are present are called alkanes, which is the one that I'm highlighting in yellow. And an alkane group is only going to have, as you can see, carbon-carbon and carbon-hydrogen single bonds. Then we have specifically the alkenes. And when it comes to identifying how do we know that something is an alkene, is going to contain one or more carbon-carbon double bonds. The next member or the next functional group in the hydrocarbon family is going to be an alkyne. And alkynes are going to contain one or more carbon-carbon triple bonds. Then we proceed to talk about the next member of the hydrocarbon family, or the next functional group in the hydrocarbon family, and those are going to be arenes. And arenes, which are also known as aromatic compounds. And remember that this concept of aromatic compounds is because of the benzene ring. This benzene ring that is going to be present in arenes is going to be a cyclic molecule that contains 6 carbons, and it has alternating double bonds and single bonds. It is important to illustrate because of the chemical test that we will be discussing at the end of this talk, that when it comes to hydrocarbons, we can have 2 classes of hydrocarbons. We can have saturated hydrocarbons and unsaturated hydrocarbons. And the difference between the two is that saturated hydrocarbons and the functional group that is considered a saturated hydrocarbon is going to be an alkane. We call it saturated because those carbon atoms are going to be, or they're going to be bonded to the largest numbers of hydrogens that carbon can have. In addition to having a saturated hydrocarbon, we can also have unsaturated hydrocarbons. And in the case of unsaturated hydrocarbons, those unsaturated hydrocarbons are going to be hydrocarbons that have less than the maximum amount of the hydrogen atoms that a carbon can hold. So the members specifically of hydrocarbons that are unsaturated that we've typically discussed in this course are going to be alkenes and alkynes. Remember that alkanes are going to be saturated hydrocarbons. Let's move on to look at the next group of functional groups that are going to be part of the oxygen heteroatomic family. It is called a heteroatom because any heteroatom is going to be an atom from the periodic table that it is not a carbon atom. So, out of the oxygen heteroatomics, we have two members. The first one is an alcohol. And what makes an alcohol have its signature attachment is that we need to have a carbon atom that is bonded to an OH group. And that OH group is what we call a hydroxyl group. Now, that carbon atom can be bonded by three hydrogens. It can be bonded by carbon chains. And you may notice that some of the structures that are illustrated here have these groups that are called R groups. R represents the rest of the molecule. And it is important to note that when it comes to alcohols, those R groups that are bonded to the carbon that contains the OH are going to be able to be used in the classification of the type of alcohol that we have. As you can see, right below where I introduced the alcohols, we have the categories primary, secondary, and tertiary. And if we look closely at what makes it or what makes a particular alcohol primary, is going to be specifically what or the number of carbon chains that we have attached to the carbon atom that is holding the OH. So if I take a closer look to the molecules here, the carbon atom, because we have skeletal structures, the carbon atom that is holding the OH is bonded to two hydrogens. As you can see, when we look down the road at this skeletal structure, it has a CH2 here and a CH3 here. So because the carbon atom that is holding the OH is bonded to two hydrogens, and only one carbon chain, so that is when we look down the arrows that I'm drawing, that's why that group is called primary. In the case of a secondary alcohol, the carbon that is holding the OH will be bonded to one hydrogen and two carbon chains. In the following example, we can see that the two carbon chains that are attached to the carbon that is holding the OH, as you can see, they're methyl groups. One this direction and one in this direction. Lastly, we can have alcohols that are considered tertiary. And when it comes to a tertiary alcohol, understand that the carbon atom that is holding the OH will be bonded to three separate carbon chains. In the example that we have here, it is bonded to a CH3, it is bonded to a CH3, and it is bonded to a CH2 that is bonded to a CH3. So you can see by looking at the arrows that the carbon that is holding the OH is bonded to one carbon chain, two carbon chains, and three carbon chains. And that's what makes it tertiary. Another functional group that is part of the oxygen heteroatomics are going to be ethers. And in order for a molecule to be considered an ether, understand that the oxygen atom has to be bonded to carbon chains on either side. In this example, we have methyl groups as carbon chains holding that single bond oxygen that it is in the middle. Then we proceed to look at the halogen heteroatomics. Halogen heteroatomics are also known as alkyl halide. As you can see, here we also have the R group present, and we have specifically determined that that R group can be a methyl group, it can be an ethyl group. This is just the chemical formulas for those, etc. What that means is that R group, it can be any carbon chain. Now, the reason why this is called an alkyl halide is because X represents the elements that are from group 7A in the periodic table. What that means is that X, that halogen, can be fluorine, chlorine, bromine, or iodine. The next family of functional groups is the carbonyl compounds. And a carbonyl compound is going to be that group that you can see the structure right here, in which the carbon atom is bonded to oxygen via a double bond. So that's what we know as a carbonyl group. There are several functional groups that are part of the carbonyl compound family, and those include aldehydes, ketones, carboxylic acids, esters, and amines. And as you can see in their structure, each of them in these skeletal structures, we can see specifically that carbonyl group. Now, what makes an aldehyde be called an aldehyde is that that carbonyl group must be bonded to a hydrogen on one side. The rest of the molecule, in other words, the R group for an aldehyde, it can be a hydrogen or it can be a carbon chain. When we have a ketone, which is the next functional group, ketones, on the other hand, the R groups, and I'm going to write it down, R and R prime must be carbon chains. Because what makes a ketone be called that functional group is where you have a carbonyl in the middle, and on either side you have carbon atoms with continuous attachment to carbons or attachment to hydrogens, depending on the carbon chains that we have. Let me just write here that R for an aldehyde can be H or carbon chains. Let's move on to the next functional group, which are carboxylic acids. And in order to have a carboxylic acid attached to a carbonyl, we must have a hydroxyl group. The R group in carboxylic acids, similar to what we saw in aldehydes, can be a hydrogen or it can be carbon chains. The next functional group is an ester. Now, the carbonyl, carbon in an ester is in the middle, and to one side it must have a single bond to oxygen. That's what makes it an ester. And it must be bonded on that symbol of R prime, which again is just to differentiate in the case that you have two chains or either side of the molecule. You can call one R, you can call the other one R prime. In this case, understand that R prime must be a carbon chain in order for us to call a particular structure to have an ester. R on the other side of the ester, it can be a hydrogen or it can be a carbon chain. Lastly, we have amines as a functional group. And what makes an amide be called an amide is that the carbonyl group is bonded to nitrogen. Now, as you can see here, we have three R symbols, R prime, R double prime, and just R. In this case, understand that R prime or R double prime can be hydrogen or it can be carbon chains. The letter R by itself, it can be hydrogen or it can be carbon chains. The next functional group are going to be amines. And when it comes to amines, understand that amines are derivatives of ammonia. Now, these amines are going to have carbon atoms attached to the nitrogen atom. So R, in this case, is going to be representing carbon chains. Similar to alcohols, amines can be classified as primary, secondary, and tertiary. Now, in the case of amines, it is going to be based on the carbon chains that are attached to the nitrogen. As you can see, that second structure says that we have a primary amine. And in a primary amine, we're going to be attached to one carbon chain or one R. In a secondary amine, we are going to be attached to two carbon chains or two Rs. And lastly, in a tertiary amine, we are going to attach that nitrogen atom to three different carbon chains. So understand that we have one more functional group that we need to mention, and that's the one that has sulfur in it. When it comes to the functional groups that have sulfur, we only have one member of that family, which is called the thiol group. What makes that functional group be called the thiol is going to be specifically that the carbon atom, or one of the carbon atoms in the structure, is attached to a SH group. Now, here you can see that the rest of the molecule, in other words, the R groups, are labeled by numbers, R1, R2, R3. For this molecule, R1, R2, and R3 can be hydrogen or carbon chains. Now that I introduced to you all of the different members or the different families of functional groups, now we are going to go over the chemical tests that you will be exploring in this lab in order to understand some of the functional groups. Understand that in this lab, for the experimental procedure, you will be watching YouTube videos, and in the lab sheet, there's going to be questions that need to be answered based on those YouTube videos, and then you're going to proceed to answer some questions in the lab quiz based on the answers that you wrote down for the questions in the lab sheet. The first chemical test that you guys will be investigating in this lab, it is called testing for unsaturated hydrocarbons. In other words, you'll be exploring the bromine test. As you can see in the reaction that is given right below the title. In this reaction, because you're testing for unsaturation, the molecules that are going to be specifically reactive in this test is going to be unsaturated hydrocarbons. So for example, alkenes in the presence of Br2 are going to form an alkyl halide. Specifically a dihalide, because in this addition reaction, each of the halogens, in this case bromine, are going to be added to the carbons that used to be double bonded to one another. How does the bromine test actually look like? As you can see in the bottom figure, if you have a chemical sample, okay, and that chemical sample is a saturated hydrocarbon, meaning that it has no double bonds, the solution will remain the color of the bromine water. That's why you see that if you have in the sample a saturated hydrocarbon, the solution remains orange. On the other hand, if in your sample you have an unsaturated hydrocarbon, because it will be reactive with that bromine water, and that alkyl halide that is produced does not have any color, meaning it is colorless, you will see that the reagent itself immediately upon that bromine water touching it is going to turn to clear. Again, is because it is reacting with the incoming bromine. And remember that this alkyl halide is colorless. The next test that you guys are exploring in this lab is the Lucas test. And in the Lucas test, you will be testing for the different types of alcohols that I mentioned in the beginning of this video. In the Lucas test, if you take an alcohol and you react it with hydrochloric acid and zinc chloride, you're going to be making an alkyl halide. Now, the alkyl halide in the Lucas test is going to look very different from the one in the bromine test. In the Lucas test specifically, we are looking for an alkyl halide that looks cloudy. So the indication of a cloudy solution will tell you that the reaction proceeded. You will be looking at the YouTube videos, and in the Lucas test, you can differentiate between a primary alcohol a secondary alcohol, and a tertiary alcohol. In the YouTube video that you have in the lab sheet, you will see that tertiary alcohols, upon adding the Lucas reagent, which is the HCl and the zinc chloride, it's going to turn cloudy immediately. On the other hand, the secondary alcohols and the primary alcohols, they're going to remain clear at room temperature. Now, it is important to note that the way that you can distinguish a secondary alcohol from a primary alcohol is that if you heat the primary alcohol or the secondary alcohol, one of them is going to turn cloudy. And as you can see in the notes here, because cloudy is an indication of a reactive molecule, the secondary alcohol after heating will turn cloudy. You will know that your sample is a primary alcohol because even after heating, it's going to remain clear. So understand that a primary alcohol remains clear at room temperature and after heating. The last chemical test that you guys will be observing and collecting data on is the tollens test. The tollens test is actually an oxidation reaction in which we know that aldehydes specifically will be able to undergo oxidation and is going to produce a carboxylic acid. In turn, because this is an oxidation reduction reaction, there is a molecule here that needs to undergo reduction. And what undergoes reduction is the silver molecule. It goes from being an ion to creating silver in solid form. That's why if you have a sample that has an aldehyde in the before status, before the reaction, we are going to see a clear solution. Upon putting the reagents for the tollens test, we will see that our aldehyde will be converted via oxidation to a carboxylic acid, and because the silver will be precipitating in the form of silver solid, you will see that your test tube or the container will have now a silver color. And that's because your reactant was an aldehyde and the creation of that silver color will be produced.